In this video, we're going to cover the second part of the 4.4 section for Pre-Calc 1. Last class, we covered the first two learning objectives here. We use logarithm properties to expand logarithmic expressions, and we use logarithmic properties to condense logarithmic expressions. Obviously, these work in tandem with one another, and they serve almost as direct opposites of one another. Today, what we're going to do is use these properties to solve logarithmic and exponential equations. So right out of the gate, this equation is kind of mind-bending. Here's what we're saying. Choose some number in your mind. We'll call this number pound, or the number sign rather, not hashtag. Here's what's happening. We're going to take some string of 2's multiplied together. Now, how many 2's are there? Well, take your number and double it and then subtract 5 from it. That's how many 2's there are. And that's going to give us the same number as if I were to take a number of 7's and multiply them together. Now, how many 7's? Well, take that number you had before, triple it, and then subtract 7 from it. This is insane if we think about this. If I take some number of 2's and I multiply them together, we know we should end up with an even number. Further, if I take some string of 7's and multiply them together, I should end up with an odd number. So this notion of an even number ending up equaling to an odd number should be troubling. But the reality is, this guy here, the number that we chose, was probably way too nice to begin with. The reality is that it's going to be some crazy decimal. It's going to be an absurd number. And so what we're going to do in this problem is solve this equation, which is going to be, it's not going to be a tall order at all. But the result, we should probably prepare our spirits for something a little crazy. Okay? Now, here's how we're going to go about doing this. There's two methods that we can actually utilize here. So, one, we could take the log of both sides. Obviously, it could be log, it could be ln. Our other option is to utilize exponent rules. We could use either of these. I'll tell you now. So for this first method, what you're going to have is a simple procedure with a ton of algebra. Whereas for the second method, you're going to have a complex procedure with very little algebra. Sorry, we put my son down for a nap and he's making hilarious sounds in the bedroom and my wife is laughing at him. So these are our options. We're going to start with the first one. Students by and large are going to gravitate towards this method. All right, so we're going to take the log of both sides. For this one, we'll go ahead and use ln. Why not? So you've got ln of 2 raised to the 2x minus 5 equals ln of 7 raised to the 3x minus 7. Since we're using logs now, we can take these exponents and ratchet them out front. Now, remember that ln of 2 and ln of 7 is just a number. They're going to be weird numbers. They're definitely going to be decimals, but they are in fact just numbers. So keep that in mind when we're starting to push these variables around. Now from here, this is where what we're going to need to do is get all of the x terms on one side of the equal sign and then we'll get all of just the straight up numbers on the other side. So what we're going to need to do here is blow this up and get all of our x terms out in the open. So now we've got 2x ln of 2 minus 5 ln of 2 is equal to 3x ln of 7 minus 7 ln of 7. And now what we've decided was that we want to get the x terms on the left-hand side of the equation, just, because that's what we're used to doing. So what I'm going to need to do is take this 3x and move it over here. I'm going to do this by subtraction. And then what I'm also going to have to do is take this number here and move it over here. I'm going to do that by virtue of addition because that's a negative. So I'll leave you to do that intermediate step. And what I end up with is 2x ln of 2 minus 3x ln of 7. And that's equal to 5 ln of 2 minus 7 ln of 7. Okay. Now both of these have an x term, so I'm going to factor out the x. Now, believe it or not, we're basically done. So from here, this thing is just a number. So I'm going to go ahead and divide both sides by it. And then I've gotten the x by itself, which is pretty cool. That was the intention. Now what we end up with as our final result just to be clear, this number is in fact horrifying. And the decimal expression of this is not going to do us any favors. If Lumen is asking for a decimal expression, say like, I don't know, they tend to ask for like 3 decimal places, then typing this into a calculator is not that tall of an order. But if it's not, you do well, honestly, to just type this thing in as it's written to give it the exact value. Now, if you want to know what this decimal approximation comes out to be, it doesn't matter. Don't worry about it. In the grand scheme of things, what this number would come out to be, if you're really into that thing, it's going to be, let me make sure that I've got my number crunching here correct. Sorry. 2.28 bloody 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 blah. Who cares? Doesn't matter. In the grand scheme of things, this is exact, and this is what we want. Now, I'm going to show you another way to do this. So if this way is actually satisfying to you, and you feel confident doing this, what I would do is go into the homework, try a problem like this, and pause the video and fast forward it. Because if you feel comfortable with this method, you don't need to worry about the second one. So here, we're going to do something a little bit different. In this procedure, what we found was that there were a lot of steps and a lot of algebra, but the procedure was actually pretty straightforward. Take the log of both sides, use a log property, push variables around, solve for x. Here, what we're going to do is we're going to use exponent rules. We're going to use exponent properties. So here's a few that we're going to use. The first of which, a to the negative 1, or to the negative k, we'll say, that's 1 over a to the k. Another one we're going to use, a to the b plus c, that's the same thing as a to the b times a to the c. Okay? And then another one that we're going to use is a to the b to the c power is a to the b times c. All right, now let's start by rewriting these. I can think of this using my second property as 2 raised to the 2x times 2 to the negative 5 power. And that's 7 to the 3x minus, or I'm sorry, times 7 to the negative 7 power. I can now use my C property here and say, okay, I'll use power to a power. And so now I get 4 to the x power times 2 to the negative 5th is equal to 343x times 7 to the negative 7. All right, now I'm going to use my first property here, and I get 4 to the x over 2 to the 5th. And then I've got 343 to the x power over 7 to the 7th. Now, these are two proportions that equal each other. So what I'm going to do is use cross multiplication. And I end up with 4 raised to the x times 7 to the 7th power is equal to 343x times 2 to the 5th power. I'm not going to worry about writing these as numbers yet. I'm not worried about that. Now, what I'm going to do is get the x terms on the same side. So I'm going to use division to move this guy over here. And I'm going to use division to move this guy over here. So I've got the numbers on the same side. And so now what I end up with is 4 raised to the x over 343 raised to the x power is equal to 2 to the 5th divided by 4 to the 7th, which means I could also take this term and rewrite it as, sorry, that's my cat. Everybody in the McKinnon household is up and at 'em today. 4, you know what I did? I changed a 7 to a 4 magically. That was dumb. Oh, there's my dog. Perfect. Got the whole team here. So we've got 4 over 343 to the x equals 2 to the 5th over 7 to the 7th. From here, I'm actually just going to go ahead and rewrite this as a log. So I'm going to say log 4 over 343, 2 to the 5th, 7 to the 7th is equal to x. And believe it or not, I could quite literally just leave it like this. And this is truly an exact value. Now, here's a concern I'm sure that you're having. This number looks absolutely nothing like this number, but they are in fact exactly the same, okay? So, two different methods give us two different expressions of the same answer. Nothing wrong with that. Now, let's solve this equation. This is going to be a little bit easier, and I'll tell you now, you could also use the same two methods if you wanted. You can either take log both sides, or you could use exponent properties. Whatever you choose to use, as long as you do it correctly, all is well. I'll give you a second to go ahead and do this. Pause the video and work this problem out on your own. Okay, so let's take the log of both sides. I'm going to use I used ln last time, I'll use natural log this time. So we start by taking the log. Right now, since I've got multiplication inside of the log, that's going to change to addition outside of them. Okay. Now I'm going to take I'm going to use my exponent properties, crank those x's out front. Now, here are my x terms. I'm going to get those on the same side of the equation. I'm going to move this guy over here by subtraction. And I've got a numerical term over here. I'm going to move this guy over here by subtraction as well. So now on my log side of the equation, I've got x log 1.07 minus x log 1.13. And that's going to be equal to log of 8 minus log of 20. I'm going to factor out my x on this side. Now, this whole thing here, this is just a number. So I'm going to divide both sides by that, and I'm done. And I'm not going to use the highlighter to write this because that's going to look horrifying. So I get x is equal to log of 8 minus log of 20 divided by log of 1.07 . All right, now, what kind of number is this? This is a little bit over 16. This is going to be a crazy number, but again, doesn't matter. This is the exact expression of it. I would not mess around with anything else. I'm going to leave the exponent properties method to your own to work, just so that the video doesn't get too long. But whatever method that you choose to use, just stick with that one, honestly. Try not to method shop for too long. In the grand scheme of things, the way that you're going to go about solving these problems, it requires commitment. And that's going to be the thing you're going to have to do. Choose a method, commit yourself to it. For better or worse, that's how you're going to solve it. Now, this looks a little crazy. This is a logarithmic equation. And I know most of us, when we see logs, we tend to bristle. But this is actually really straightforward. In order to solve this one, what I'm just going to do is convert this into exponential. So what I'm saying is log base 2 of 6x plus 4 is equal to 1. So 2 raised to the 1 power is equal to 6x plus 4. Well, that's just 2 is equal to 6x plus 4. I'm going to subtract 4 from both sides. Divide by 6. X is equal to negative 2 over 6, which is negative 1 over 3. Now, from 4.5, I think it was, when we talked about logarithmic graphs, we cannot put a negative number or a 0 into a logarithm. You can't do it. So what we need to do here is we need to actually check our work. This now becomes mandatory. So what I'm going to do is just plug this number in, and let's see if anything bad happens. So 6 times negative 1/3, that's negative 2 plus 4. Well, negative 2 plus 4, that's going to be 2. That's a positive number. So what I'm saying is log base 2 of 2 is equal to 1. That's fine. I'm plugging a positive number into a log. All is well with the kingdom. This checks out. If it didn't check out, this would be what we call an extraneous solution, where just because we got the answer from a line of algebra, that doesn't mean that that answer actually serves as a solution when we consider the original context of the problem. Now, in this problem, we want to solve for x. So, in order to solve this, what we're going to have to do is use a log property that you all know and love, and then we're going to use a lot of algebra to work this out. I'm going to give you a second to try this one on your own. Okay, so the way that we're going to go about this, I see a plus outside, a sum outside of the logs. That means I'm looking at a product inside of the logs. And this is log base 10, just so that we have that in front of us. I'm going to distribute this x. And just like in the last problem, the way that I unfurled this log expression to make things at least a little bit more savory was I converted this into an exponential. So let's do that. So I'm going to convert this thing into an exponential. So I'm going to say 10 raised to the third power is equal to x squared plus 4x. Well, that's really just 1,000 equals x squared plus 4x. This is a quadratic equation. I know how to solve this. I'm going to start by subtracting the 1,000 from both sides. And I get this expression here. Now from here, we could use quadratic formula, or we could use factoring. I'll tell you, factoring is going to very quickly show itself to be not a great idea. So we're going to need to use the quadratic formula. So that's going to be x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. I'm going to leave you to plug these particular numbers in on your own, okay? And so after I mash this into the quadratic equation, after I mash the coefficients in, I end up with x is equal to negative 4 plus or minus the square root of 16 plus 4,000 all over 2. Now, 16 plus 4,000, it's just going to be 4,016. Now, for simplifying the square root of 4,016, I'm going to say, well, that's 4 times 1,004, which that's going to break down really nicely to 4 and 251. So I've got a pair of 4s here, which is kind of nice. So I'm going to take a 4 out. 251. And now I'm going to reduce. I see that we've got, if I were to factor out a 2 from this numerator, it would reduce with this 2 in the denominator, and I'd end up with negative 2 plus or minus 2 square root of 251. And I've got these two solutions now. Cool. So naturally, these are both my answers, and all is well with the kingdom, and everybody wins. That is actually not true. So what happens is, for this first solution, just as a perfect example, this number, -2 minus 2 square root of 251, if I write this out as a decimal, I end up with -33.69, blah, 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 blah. Okay. Well, it's 0.68, blah, 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 blah. So that's just boom. Now, if I took this number here and tried to plug this into the original equation, I'd be putting a negative number into that log. So that's not going to work. This is what we call an extraneous solution. This doesn't actually work as a solution. This is an answer, but it is not a solution. This number here comes out to 29.68, blah, 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 blah. This number has absolutely no problem plugging in here or here. All is well with the kingdom. And if you do plug this number in with, a little bit of rounding error, this number here is going to end up being our solution. It's really important that you consider extraneous solutions. Checking your work is now mandatory. You got to do it. Okay. I want you to solve this equation. It's not going to be fundamentally different than the last one. Take a second, try it for yourself. Obviously, pause the video. All right. Right out of the gate, I see a subtraction outside of the logs. That's a division inside of the logs. And now I've got a logarithmic expression. Let's rewrite this as an exponential. 2 to the 7th. I'll tell you, 2 to the 7th, let's not make this grosser than it already is. That 2 to the 7th, that's just going to be 128. And now what I'm going to do is multiply both sides by x plus 1 so that I get rid of this denominator. And I'll go ahead and distribute that through. And so now I end up with x squared is equal to 128x plus 128. And now this is a quadratic. So I'm going to subtract 128 from both 8x from both sides and then 128 from both sides. And I end up with the equation from here. You're going to either utilize quadratic formula or factoring. I'll tell you right now, you are definitely going to use the quadratic formula. Okay, we're definitely going to use the quadratic formula. I'm going to leave those details to you. Now, when you use the quadratic formula, you're going to come out with two things. You're going to have 64 plus 8 square root of 66 and 64 minus 8 square root of 66. Whew, that's going to be crazy. That's okay. That's fine. Now, here's the thing. You're going to get two answers for this. One of them is going to be 128.99, blah, 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 blah. Okay? And then this one is going to be negative 0.99, blah, 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 blah. So here's the thing. If you take this number here and you plug it in, you're going to get squared. That's going to be a positive number. We're cool. You can totally log a positive number. That's great. Let me do this in different colors so that you can see how we're kind of checking these. So for this number here, we plug it in here, we square it, positive, boom, log of a positive, that's cool. And then we're going to add 1 to an already positive number, log it, that's fine. Now let's check this guy out, negative 0.99. All right, well, first I'll square it. All right, well, squaring a negative makes it positive, we're good. And now here's the thing, negative 0.9999999. When I add 1 to that, that's going to be a positive number. So I'm logging this a positive number. All is well with the kingdom. Both of these are going to be solutions. Now, my advice to you when typing this into Lumen, these are going to be the ways, or this is going to be the way that you should probably express it, just to make sure that there's no rounding error or anything that's going wrong there. This is the second part of 4.4. Please email if you have any questions. Attend virtual office hours. The ARC is still available. Good luck out there.